In this lecture, we'll keep working on geometric sequence. Okay, they are all geometric sequences. Basically, we want to get formula we have learned. Two important formulas. Here we have 3 examples. Let's look at the first one. The first one is asking us to find the expression for the general term a sub n and also the special term a fifth for the geometric sequence. We know this is a1, this is a2, a3, a4. So how does it look like for a fifth? Look, first of all, we need R, the ratio. R is always the next term divided by the first term. And we know this is 3. So we know I is 3. Basically, you can see right here, negative 3 times 3, you have a 9, negative. And if you use 3 to times negative 9, you have a negative 27. If you use another 3 to times negative 27, you have a negative 81. Okay, you can see right here. Negative 27 times 3 is negative 81. So it's not hard for you to figure out a to the a fifth. Okay, but you know, right down here is that we want to understand a sub n is the formula right here is a1 to the n minus 1. Okay, and then we have a1 is negative 3, and here is 3 to the n minus 1. Okay. Yeah. Again, you know, if n is 1, 1 minus 1 is 0. 3 to the 0 is not 0. Is 1. So 1 times negative 3 is what? Is a1. So this one also works for itself. Okay. Yeah. So basically, you can see here is that the first term, a1, multiplied by 1, 3, you get that. Multiplied by 3 squared, you get that. This one. Multiplied by 3 cubed, you get this one. Okay. Again, the exponent is always 1 less than the sub-index here. Okay. So a fifth is negative 3 times 3 to the 5 minus 1, Okay, so what do we get? Negative 3 times 3 to the 4th. Okay, 3 to the 4th is 81, Okay, and then times what? Times negative 3. So you see, we have a negative 3 times 3 to the 4th. Okay, so it's negative 243. Actually, you know from here, because negative 81 times 3 is negative 243. Okay, This formula should be easy to remember. Okay, it's like the arithmetic sequence. Okay, you add one difference, you get the second one. You get another, add two differences, you get the third one. You get three differences, add three differences, you get the fourth one. Here is just exponent. Okay, you times 1r, you get second, times r squared, you get third, times r cubed, you get fourth. Times r to the fourth, you get fifth. The same. Okay? Similar. Not exactly the same. Now here, the second one is that we need a 1 and r for the given geometric sequence right here. Okay? Again, you got to use this formula. So the purpose of the exercise is you want to apply this formula a lot. Even we know geometric sequence is all the time the first one times size the second one times size the third one. Okay, but we always want to apply this formula to make our life easier. All right, yeah. Now down here we have what? We know A2 and we know A5. So we got to write, I don't want to write this general formula anymore, huh? So I want to do is what? Here is 2, you plug in, so you have A2 is A1 times 2 minus r, is r times 2 minus 1, okay? Is based on this formula. You plug in 2 here, 2, 2, okay, then you will have a 2 minus 1 here, here is 2. Alright, so basically is a 2 equals a 1 r. Again, a 1 times r is a 2, huh? Now, here is a fifth, a 1 is r to the fourth. Okay, yeah, so I do not have to repeat like 5 minus 1. Okay, right down here. Now, okay, let's see what do we get. Down here we then have a 2, we know, negative 3, so you plug in 3 here. Okay, and then equals a 1 r. And here we also know a sub 5, which is negative 81. So negative 81 you put right here equals a 1 times r to the fourth. Okay, like that, because we know a 5. Okay, and here we know A2. So you have 2 equations, all right? We have 2 equations. Let's mark this one is star 1. There are 2 stars right here, okay? Now, I like to do is what? The second one divided by the first one. Why? You will find out. That's the technique. Then you have 81 upstairs divided by 3, because it's the following one divided by the above. And then here will be a 1 r to the fourth, right? This one. Yeah. Downstairs is a 1 r. Now what do we get? Left hand side is negative 81 divided by negative 3. We get is 27, huh? Okay. And here A1 are cancelled. A r to the fourth r, so you have a cubed. And then there is no problem for us to get I is what? R is 3. So you find your R already. Okay. If you have R, then what do you get? You plug in back here. Okay. So what we get will be negative 3 equals A1 times 3. So this gives us A1 times, let me use star. Oh, A1, that was 1. Okay. Let me write here is, this is A1. Okay. Then what is A1? There is no problem for you to get negative 1. Okay? It's because negative 1 times positive 3, you have negative 3. So you have found what? R is 3, A1 is just negative 1. Okay? So we're clear right here, huh? Now let's work on the last one. The last one is use the formula. What formula? A sub n. Remember, A sub n is A1 times 1 minus R to the n divided by 1 minus R. Okay? That's the formula you're going to remember. Maybe the first time you don't remember, after you did 1 or 2, you should be able to remember it. And we have what? A1, which is 8.427, that's A1. And then times 1 minus R is right here, 2.852 to the what? How many? First 5. Okay, so here should be fifth. And then divided by 1 minus R. That's 2.852. Okay, so you plug in your calculator, you'll find out your answer. Okay, let me put calculate it for you. So 8, turn it on, and 8.427 times parenthesis 1 minus 2.852 to the 5th divided by 1 minus 2.852. To see if I did right, I want to double check it. 8.427 and 2.852, 2.852. Huh, something is wrong. You see here, I forgot one bracket. Okay, second insert this one. Okay, if that one was not there, it would be a disaster. Huh. So hit enter. Then the answer we get will be 854.0. You want to round it, so 3. Okay, 854.03. That's the final answer. You may want to do it. Here is approximately. Alright. So again, this lecture is want you to get familiar with the formula here and here. Okay, those two examples are very typical in geometric sequences. Okay, I'll see you next time.